Assalamualaikum warahmatullahi wabarakatuh, and good day to all. So today we will cover on the second part of chapter 3, precision, accuracy and error. So in this slide we need to ensure that we cover our lesson outcome number 1 and number 3. So before we proceed, we need to call back the single and double precision plotting point form, and also the formula that we will use if we want to convert from single or double precision to the decimal representation. So first of all, we learn on how to convert the decimal representation to single or double precision plotting point form. So what you need to do, you need to have these 4 steps. The first step is convert the equation to base 2. So you are given decimal number, so you will convert it to base 2, meaning your answer will be given as 01. Second, you change your answer in 1 to the 1 plus form. 1 plus form means you will represent as 1 point something. For example, you have the answer as 10.10, so it will come as the final answer 1.010 times 2 to the power of 1. The power of the 1 plus form will represent the C. So the power of 2 previously in 2, 1 means you need to convert in binary. So that value actually represent the second term in single or double precision plotting point form. The first one is the number in 2 after the plotting point will represent the third term of single precision plotting point form or double precision plotting point form. Okay, so we come to the first example where we want to convert this negative 22.5 to single precision plotting point form and also to double precision plotting point form. So step number 1, number 2 is same, the difference is just on the step number 3. This is because the power of 2 in the formula for the single precision is C minus 1 to 7, while for double is C minus 10 to 3. So first we need to convert the decimal number to binary base 2. Since you see here the number is 22.5, so we can ignore the negative first because the negative is just put on the sign. So we know that this sign later will come as 1 because it is negative. So we just convert the 22. So by using calculator, you can have it is equal to 10110 base 2. Okay, for the plotting point 5, you need to multiply by 2, and you will read the answer from top to the bottom. Okay, you will times with 2 until you get the remainder as 0. For example, here you have 0.5, so 0.5 times 2 is 1. So we put 1 as the integer, so the remainder is 0. So the answer is 0.1. So when you sum up, this one is 10110.1 base 2. To ensure that you understand the other example, if when you want to convert the 0.1 to 5 to binary, so you just multiply 0.125 to 2, so you got 0.25, so the integer is 0, so we put 0 is 0, so the remainder is still 0.25 because 0.25 minus 0 is 0.25. So again, since it's not 0, you need to multiply with 2, so you got the answer as 0.5. Okay, so in the integer here 0, so 0, 0.5 minus 0 is still 0.5. You times with 2, you got 1, so the integer is 1, so 1 minus 1, so the answer is 0, so you need to stop, so your answer will be given as 001. The plotting point of decimal representation of 0.125 is actually equal to 0.001 base 2. Okay, so we go for the second step where we need to change the answer in 1 to the 1 plus form. If you remember previously, you have your final answer as 10110.1. This is not in 1 plus form. Okay, so what we need to do is you move the point until you got 1 plus 4. So you will see here 1 2 3 4. So 1.01101 times 2 to the power of 4, because you're moving 4. Okay, this value represents the value of C minus 1 to 7. So on the third step, what you need to do is you need to find the C. So since C minus 1 to 7 is 4, so your C is 131, sorry. So again, by using your calculator, you need to convert the C to the binary. Okay, so you will get the answer is 10000011 base 2. Please ensure don't left the base. Okay, if not, it will give you the wrong answer. So step number 4, we need to represent it in the single precision floating point form. So since your equation is negative, if you remember, the equation is converting negative 22.5. So that's why we put 1 here. Okay, this one we taken from 3. Okay, so you see here you have 1 2 3 4 5 6 7 8. Okay, so equal 8 bit. So how we put it? You put it from right to the left. Okay, so this one put here 1 1 0 0 until the last one is 1. If for example here you got the answer as 110000 that you read from right to the left, so you have 2 empty bits. What you need to do is you put a 0 on the empty bits. Okay, for the third term, you need to take from 2 after the floating point here. So you just take directly from here. The answer is 01101. So you just put 01101. The other rest you need to fill up with 0. So your final answer is given by this. Okay, so we move for the same example, but we converting to double precision floating point form. Okay, step number 1, step number 2 is same. Okay, so the difference is on step number 3, because the power of 2 in number 2 here represent the value of C minus 1023 in double. So C minus 1023 is equal to 4, so you can find out that your C is 1027. So again, you need to convert this to binary. Okay, so you will get the answer as 1000000011 base 2. This one you can convert either by using calculator or by using manually. Then what you need to do on the step number 4, you need to represent in double precision floating point form. Again, since the equation is negative 22.5, so you need to put 1 as the sign since negative. This one you taken from number 3. So you see here you have 1 2 3 4 5 6 7 8 9 10 11. Okay, since this is 11, it's completely to fill up on your second term. And the last one, we take it from 2, number after the dot, and you see here 01101. So you just put here 01101, and then the rest you put 0 until for the location of B0. So your final answer is represented by this. And you need to ensure your total bits on your third term is 52 bits and the whole total bit is 64 bits. That's all for today. Thank you.